Welcome to Photonics In Focus, the podcast where industry leaders and innovators share insights into the latest advancements in integrated photonics technology. Join us as we explore how this emerging technology is transforming industries and driving new possibilities, and how AIM Photonics is at the forefront of this revolution. Tune in to stay ahead of the curve in the rapidly evolving world of photonics.
Welcome to today's episode of the Photonics in Focus, where we spotlight the future of integrated photonics by hearing directly from some of the students helping to shape it. Each year, AIM Photonics offers hands-on internship opportunities for highly qualified undergraduate and graduate students to work alongside our engineers and researchers in our advanced manufacturing and R&D facilities in Albany and Rochester, New York. These internships give students real-world experience of photonic integrated circuit design, fabrication, testing, and packaging, preparing them for high-impact careers in the U.S. integrated photonics industry. My name is Bob Geer. I'm the director of the Education and Workforce Development Program at AIM Photonics. Today, I'm joined by some of our summer interns, as well as my colleague from New York Creates, Andrada Niculae, who has helped coordinate their placement in internship experiences. We'll start with a brief discussion about the value of experiential learning and how internships like these at AIM Photonics help build the talent pipeline for the integrated photonics field. Then we'll hear directly from the interns about the work they've done and where they hope to go next. So, first things first, Andrada, thanks so much for being here. As I mentioned before, you're the Experiential Learning Coordinator here at New York Creates, and you've been working with AIM Photonics to help place these students. You've been instrumental in helping provide these students with meaningful internships with AIM Photonics this summer, working with their supervisors, working with their mentors. Can you talk a bit about the recruitment process, what it involves, and how the students are selected and matched with their projects and mentors?
Sure. Thank you so much for having me here. I would like to start by saying that our recruitment process follows a structured path to ensure the best match between students, projects, and mentors or supervisors. Of course, I got to tell you that we received hundreds of applications, so it's not an easy task to go over so many amazing resumes. Of course, we always go with the best students, and when we usually look at an application, we consider the students' degrees, whether or not they had any relevant experience, whether they provide us with a set of skills as well that we think they might be beneficial. Of course, there is a whole process when it comes to the internship planning. It's about defining project scopes that are suitable for interns, identifying mentors or supervisors, and also setting goals like skills development and talent pipeline building, as well as research support.
Oh, great. Thanks so much. You've got a very unique vantage point working with these students, recruiting them, matching them to projects. What kind of impact do you see these internships having on the students when they're here?
So I think that myself as an experiential learning coordinator, I would say in the unique position of observing and actually supporting the students to this transformational opportunity. Because at the end of the day, internships are not just resume boosters. Actually, they're totally shaping the students' personal, professional, and academic development. And then if we think about some key factors around the internships, we can start with career advancement, for example. This is going to give our students multiple opportunities when it comes to choose their career path. And also, of course, our students have the opportunity to design their own career paths through this internship as well. Another key factor that we can talk about would be that bridging between theory and practice. How is that what they studied during their university programs applies to the hands-on that they're currently doing? You're going to see that at the end of the internship, most of our students have already developed a set of skills that probably they didn't know they had, or they had but never explored them. So there are a lot of positive aspects around the internships that we offer to our students. And this year, I want to say we have a great group of students as well.
I mean, those are fantastic points. I mean, there's no question that, the real world type of experience, you're absolutely right in that it connects them with what they're doing, in their degrees. It also, provides them with a lot of really introductory, just professional workplace skills. And then that's really, really critical because, they're going to be going out, into the workplace soon. One of the reasons AIM Photonics places such strong emphasis on education workforce development, there are several reasons. One, the U.S. photonics industry really depends on having a pipeline of skilled people. That talent is critical, and it's really part of the whole onshoring focus that the nation has to build out the advanced manufacturing capabilities here in the U.S. Also, the photonics industry is not quite as high profile as some of the semiconductor industries in general and microelectronics in general. And the fact that photonics is powering AI, is powering so much of the technology we use, it's great to get students to see that firsthand. So one of the things about building this talent pipeline, bringing in people to get hands-on experience with AIM Photonics engineers, researchers, is to be able to, give them the experience they need to start making these career choices. And that's exactly why we're excited to talk with the students themselves who have joined us this summer. They've been working on real projects, whether it's from device modeling, simulation to wafer scale data analysis, and really contributing to the same R&D and manufacturing environment that supports the our national integrated photonics infrastructure. So, of course, we've had a wonderful crop of interns this year, and we're extremely lucky to have, a group of 3 of them here today, each bringing their own academic background and goals to this conversation. So let's meet them. Let's hear directly about what they've been working on, what they've learned, and really what led them to pursue an internship here at AIM Photonics. So I'm going to go around our table here. And so for each intern, please give us your name, sort of, what academic degree program you're pursuing, obviously your home school and area of study, and, why you chose to do your internship with AIM Photonics. And I'll start with you, Robert.
All right. Hello. My name is Robert Coleman. I am a 5th-year electrical engineering PhD student at Howard University in Washington, D.C. And I decided to pursue an internship with AIM Photonics because AIM sits in a unique position between fully research closer to an academic setting and on the other end being fully manufacturing mass production industry. AIM sits in the middle, whereas they do have customers and there is an industry side. However, there's still room being made for core research and development. And I think that unique position could afford a lot of learning opportunities for people trying to get into the field.
Oh, that's a fantastic little summary. We'll move next to Anand Raj. Tell us a little bit about you.
Yeah, sure. Hi, my name is Anand Raj. So I just graduated with my Master of Science degree at Northeastern University, where I specialized in electrical and computer engineering with a focus on photonics and micro electromechanical systems. So I chose to do my internship at AIM Photonics because I've always been fascinated by this intersection of photonics and semiconductor fabrication technology. And AIM represents one of the very few places in the US who does this fusion at a national scale. So the opportunity to work on this field, especially at AIM Photonics, was very appealing to me. I knew that by working here, I would gain some understanding of the top-down and bottom-up design goals and fabrication challenges that engineers face in this field. What also drew me was AIM's reputation for providing interns with meaningful experiences. It's not just shadowing; it's just real-time experiences that you get exposed to. So yeah, that piqued my interest.
Oh, wonderful, outstanding. Melika.
Hey, first, thank you for having me here. I'm Melika Momenzadeh, a third-year PhD student at University of California, Irvine. And my major is in electrical engineering, focused on photonics. On top of what others said, I should mention that it was a great opportunity for me in a case that I have in a close contact with the mentors here, the experts here. I have access to most advanced tools and work on cutting edge and real world applications. And also, if it's a mix of everything and it's like a package. And at the end, I can say it was a great place for me to learn, grow, and work or contribute to most impactful projects.
Oh, wonderful. Thanks so much. And now for the geeky people that are listening to us, we'll maybe dive a little bit more in what you've actually been doing. Anand, we'll go ahead and start with you. You've been working with those design concepts, real world data, sort of digging into how edge couplers and photodetectors perform. Sort of walk us through what kind of data you've been analyzing, what you've been doing, and sort of your view of the research you've done.
Yeah, yes, definitely. My project involved two key components, edge couplers and photodetectors, which are essential elements in a photonic integrated circuit. I worked majorly with the measured data taken from 300 millimeter wafers fabricated through AIM Photonics MPW process. So for the edge coupler, I analyzed and plotted various loss metrics such as insertion loss, polarization dependent loss, TETM losses. And the major goal was to plot these performance metrics and draw patterns and ultimately decide which variation is better, which variation is worst. And on the photodetector side, I looked at the responsivity data, the dark current behavior, and one focus was understanding how well the real devices match with our design specs, and whether there are any trends in the data that will be traced back to the fabrication tolerances. So by comparing different dies in a wafer, I aim to identify the systematic variations which are caused due to the lithography. Yeah.
Sure. I mean, is there anything been, I don't know, anything you found really surprising, either about the data or even just the project itself, that you didn't really expect when you started it?
Absolutely. So what really stood out to me was how sensitive the device performance is to even minor variations in fabrication. So for example, in case of if you take edge couplers or photodetectors, so I have observed that a small deviation, say by 20 or 50 nanometers, can affect a lot on the optical performance. So such small variations are negligible from the design standpoint, but it can affect a lot on the device performance. Another surprising finding was how empirical data sometimes challenge our simulation. Simulation often gives you ideal behavior, assumes that the fabrication is so perfect. But when it comes to fabrications, and it has so many layers of complexity. So similarly, with these devices, I noticed some interesting patterns related to unicity across the wafer. So I could see that the devices work best when it was near the center of the wafer, and if you go through the edges of the wafer, it performed not that well. So yeah, so this realization has really shifted to how I approach problems now too. So I'm more attuned to process variability, so how process parameters can affect these performances, and I understood how important data-driven studies in the case of wafer scale analysis. Yeah.
No, I think that's great. And to be honest, I think that's, you phrased so well the difference between doing something in a lab where you're just happy to get a device to work once or twice versus trying to turn that into a technology that you can, manufacture over and over and over again. Yeah, it's not an easy thing to do. So that sounds like a great experience. So we'll move on to Melika. You mentioned your project focus was focused on laser edge couplers, visible region edge coupler simulations. Tell us a little bit about what you've been doing this summer, what you've learned, and sort of, how you worked with the engineers to sort of dig into your project.
Sure. For my project regarding to design the edge coupler, I should mention that I was trying to better understand how different parameters can have impact on the final or overall performance of the system. For example, the misalignment tolerances, some sort of insertion loss or back reflection losses, right at the intersection between the laser and the integrated circuit or integrated waveguide. I can say in general, engineers, when they are designing edge coupler, they are looking for mode matching or some sort of impedance matching between the laser and the integrated waveguide, and also minimizing the loss, the overall loss, such as the back reflection loss. That is the main cause of the destabilizing the laser. So ultimately, I can say that the purpose is not only designing a perfect theory-based design for simulation. When you're working in such a big foundry or company, it's really important to design something that at the end of the day, it will be fabricable or something that is, kind of connect to the real world application. So I can say this is the ultimate goal and that's what I have learned with.
Oh, that's great. That's fantastic. Yeah. How has it been working with the engineers? Folks that come at it with, a lot more experience than you have on the photonics side. How has that been for you?
Working with experts here, to be honest, it was really rewarding for me because I better understand that how, for example, it is a real world application design. Before, for example, during my PhD, I had this experience of working on a theory or designing part, and I knew that how I can, for example, design a photonic components. But here, I basically learned that how it is after that fab process, like, for example, testing, assembly, packaging, and how all these parameters are important in like the results of the simulation or results of the design. So I can say it's very important for me in a sense that I can see how each of these parameters and factors can have like important, even small changes of each of these parameters can have like a significant results or change to the final result. So at the end, I should mention that it's really important to consider all these after-fab parameters to the simulation of the model to have the real, or I can say scalable or robust and reliable design of it.
Oh, that's great. Well, I have to say that when you're doing a master's degree, a PhD, even if you're doing a senior project, when you're getting an undergraduate degree in engineering, a lot of times you're focused on that one project. It's you, right? And what I know we hope we give our interns is the fact that when you go out into the world, everything you're doing is part of a team, and you are working with people upstream and downstream on the technology development side and learning how to work through that, learning how to think, okay, not only what I'm doing, how it affects what I'm interested in, but how it's going to affect what everyone else needs to see, to make this a technology. So that's very exciting. And last turn to Robert, who's doing some interesting things with our QFlex technology platform. And just for the folks listening, the QFlex technology platform here at AIM Photonics is really focused on the type of technologies to support quantum communication and quantum computing. So it's a slightly different technology. But I want to turn to Robert and tell and hear about the work that you've been doing. You've been looking at simulation tools to look at how these detectors behave, and just for the folks listening, when you're working with our QFlex platform for quantum communications, you're really looking at ultra low signals. I mean, you really do need extremely low noise type of communications on the chip. Start to tell us a little bit about what you've been doing.
Well, the bulk of what I've been doing here is simulating about 7 or 8 different detector designs that have been fabricated and tested already for the purposes of, one, just seeing what type of behavior we should expect from these devices as they were designed with their own unique qualities and parameters. And secondly, comparing those ideal results to what we get from experimental, as Anand touched on. You're never going to get results that directly line up with your ideal case, your perfect case, but you can use that ideal case to guide how you interpret your experimental results. So first, like I said, we just wanted to get a baseline for what type of behavior we should expect in the ideal case, so you can have a baseline to move forward. And then when we compare it to the experimental, we can then delineate which devices work best. And from that, pull what type of design qualities, what type of design trends can we pull out to then move forward and design better detectors going forward, and decide which of these detectors we want to integrate into larger platforms.
Oh, that's outstanding. I hear you've also been building a standard script to help run these simulations more easily, from whatever data inputs you had. Can you tell us a little bit about that?
Yes. So this script is not necessarily relevant to the QFlex detectors. It'll be more used for just passive photonic components. So say your splitters, at the simplest thing, just a waveguide, maybe an edge coupler. Really the purpose of that project is to just speed up the entire design flow process for all of the engineers on the team. So that when they have, say, a simple passive component that they may have generated a layout for, generated a design for, they don't have to go into the simulation software and build up a model from scratch. Because we know if it's just a passive device, it's only going to be so many different things present. You can kind of predict what that model would look like for the most part. So we want to streamline that process such that they can just put in important parameters, important details, upload their design, and then the simulation is taken care of. All of the more detailed work of setting up a simulation that more than likely wouldn't change from passive device to passive device is going to already be locked in and set up so that when a design engineer comes along with a new design, they can just put in what their design is, specify certain key parameters, and just press go. And they can get their results back in a much more timely fashion without having to get into all of the dirty work of setting up a simulation from scratch.
Okay, so make sure that the AIM engineers send you thank you notes for the time you're saving by having this set up. Because to be honest, speaking from experience, having that configured, to speed up and to make everything so much more efficient would be fantastic. So great. These are all, just very exciting, projects you've been describing, and I'm glad you're getting the most out of the experience here. Of course, one of the whole reasons for this program, and it's one of the reasons that that I work on this, that Andrada works on this, is to connect you with these careers. That's the reason we're here. So you've been building some great technical skill sets this summer, but we also hope that this really exposes you to possible paths you can take, especially in this technology field. So I'd love to hear about, how this experience is shaping your thinking about the future. And you don't have to commit to anything, obviously. But maybe give us some thoughts on that side. Melika, this was your first internship in the U.S. I don't know. How does it compare to your past experiences? Were there any parts of the work here or the environment that have spelled that especially different or helpful? Especially as you think about the next part of your career?
Sure. Yes, it was being my first internship here in the U.S. And if I want to compare to my previous experiences in different roles, I should say that I found the place or environment supportive and collaborative. To be fair, everyone here is open to questions, feedback, and helps us a lot to learn as much as possible during the short time that we are here. And also it gave me a clear idea of how the research is connected to the real world application. And for sure, definitely helped me to better understand my future, or I can say boost my confidence about what I want to do next in my career.
Oh, that's great to hear. And, more and more there are career opportunities in these fields. I see more and more positions advertised. So, hopefully it'll make you think the next time, you look at what you're going to be doing next. We'll turn now to Anand. I know you have a path going forward. I believe you're heading back to Northeastern to start your PhD. Now that you've had this experience, working in this field here at a facility that has, one foot on the one foot on the development side, one foot on the fabrication side, has this influenced what you're thinking about the kind of role you'd like to have in the future? R&D, fabrication, what are you thinking?
So this experience has definitely helped refining my skills in research. So this is my first internship in the US. So before doing this internship, I was primarily focused on just design, thinking of myself as someone who might specialize in layout, modeling, or simulation in the future. But at AIM Photonics, I could see the full life cycle of a device, from the concept to designing it, fabricating it, and testing it. So it really opened my eyes on how interconnected all these devices are. And what I found especially rewarding was the process of looking at measurements, identifying trends or outliers, then using that information to say that this design will look better and this design will not look better. So it's that feedback loop that I want to stay involved with. So I'm now very interested in roles that combine both applied research as well as development engineering. So essentially being the bridge between R&D and manufacturing. So I want to work on real problems where I can see my contributions lead to results, whether it's optimizing a PIC layout or better yield or identifying a critical source of loss in a packaging process. Yes.
Oh, outstanding. Yeah, I mean, I think even just having that perspective is going to be valuable, especially, no matter what employer you end up going to, or, whether you decide to start a company of your own, no matter what. So now we'll sort of turn over to Robert here. You've spent this summer working on simulations. You described some of the scripts you're developing, sort of helping to, really speed up this process for the other engineers. And I know you're heading back to Howard University. So, how do you see yourself fitting in this field? Has this maybe, I don't know, given you a couple other areas to think about? What's it done for your outlook?
Well, two main things. One, it's providing me a perspective that is not at the scale of academia like I'm used to. As I'm sure you already know, kind of everything at the academic scale moves a little bit slower, and it's a little harder to get things done purely from the setting metric and the different hoops and hurdles that you have to go through at that level. Here, doing any type of design, any type of testing, anything of that nature is much more straightforward and much easier. I've been afforded all the tools that I need to complete my work, as well as the help to do so. That leads into my second point of this team has had a very, very good balance between collaboration and independence. I have never found myself here not able to ask a question, not able to go to someone for help or for input, and that's very, very much valued. But on the flip side of that, I'm also not micromanaged, which can really be a detriment to someone, especially doing this type of work when you have to you're really trying to figure things out that we don't have the answers to, right? Being micromanaged can very much hinder that process. So having this unique balance between micromanaging and collaboration is actually very good. And I can directly see how that affects all of the members of the team, whether they're working independently or coming back together for like a larger meeting to talk about results and to give suggestions and things of that nature.
Oh, fantastic. I think that's a great, perspective to walk away with, because, no matter what environment you head into, there's always going to be that balance, right, between, collaborating and advancing, whatever work you're responsible for. So, that's great to hear. So I want to thank, each of you, Andrada, Robert, Anand, Melika, for participating here. I think it was a wonderful conversation. And I know people talk a lot about internships. It's a lot more here than just checking a box, because we really do want people to understand not only the details and nuts and bolts of what we do here, but also the fact that there's some very rich career pathways here. And, we want to keep developing these technologies, and that's what AIM Photonics is all about. So no matter where you end up, academia, industry, starting an initiative on your own, joining a large company, we really hope the skills and perspective you gained here will be part of, what you carry forward. I mean, that's what we want to see. So, this is part of course, what we do at AIM Photonics here. We're committed to growing this workforce. We want to support this very rapidly evolving field of integrated photonics. It plays so many vital roles, which frankly, a lot of people don't really, quite understand. And the work you've done this summer is just absolutely contributing to that effort. So on behalf of our entire team, thank you again. We look forward to seeing, where your photonics journey is going to take you next. I'm absolutely certain all of you are going to be extremely successful.
Thanks for joining us on Photonics In Focus. Be sure to subscribe and stay tuned for more deep dives into the latest advancements with industry experts throughout the integrated photonics ecosystem. For more information about AIM Photonics and the work we're doing to advance the integrated photonics industry in the United States, please visit our website at aimphotonics.com.